Thank you everyone for registering your attendance. Before I begin the session proper, here are some housekeeping matters. Please disable your microphone and video. Please use the chat function if you need support when experiencing any technical problem. If you'd like to ask a question, please type your question in the Q&A text box, which is usually situated at the bottom of the Zoom panel. We will address some questions at the end of the introduction segment, and the rest will be addressed during the last 15 minutes of the session with all the presenters. We seek your kind understanding if we could not address all of your questions during the session, but we will try our best. The session will be recorded for documentation and internal circulation purposes. If you have additional queries, please email the address you see on the screen. That's all for the housekeeping matters. Now, please allow me to introduce our main speaker for our session today, Mr. Lim Tern Poh. Tern Poh is a principal AI consultant at AI Singapore. He provides consulting services to enable customers to undertake the development and implementation of AI minimum viable models within their organizations. He is also on secondment to Singapore's National AI Office to provide his technical expertise on AI and a visiting mentor at 500 startups. Coming from a commercial background, he understands the importance of bridging stakeholders to translate analytics insights into impact at scale. He is excited about combining his AI knowledge and capability to create exponential value for businesses and society. Without further ado, please extend a warm welcome to our presenter, Mr. Lim Tern Poh. Tern Poh, please.
Okay, thanks. Thanks for having me on this training session. So glad to be here with everybody. So again, my name is Tern Poh. I'm from AI Singapore. So I'm here today to share with you a quick introduction to AI. What is AI? And later on, we'll do a simple hands-on session to do a model predictions on student grades. So I will skip about myself since the moderator has introduced me. So before I start, let me quickly introduce who is AI Singapore, because not everybody has heard of AI Singapore. So who are we exactly? So AI Singapore, we are not a commercial entity. We are a national program office funded by the government, or NRF to be more exact. So we have started in 2017, so around 2 years plus to 3 years now. Okay, so what do we do at AI Singapore? We understand that for AI resources and talents in Singapore, it's very rare. So what we then do is that we do coordination across all the different agencies. So for example, let's say if there's any company who wants to do any like AI modeling using, let's say, maritime data, but if all maritime data is with MPA, what AI Singapore will do is that we reach out to MPA through our contacts and see whether they could do some collaboration of data sharing to enable the building of the AI model. So I work with all companies of all sizes, be it SMEs, startups, AMCs, be it public or private sector. Whoever needs AI expertise, you'll be there for them. So again, our mission in Singapore is to help Singapore accelerate the AI adoption, right, to maintain our competitiveness. Okay, that's it for AI Singapore. And at AI Singapore side, we have 3 main pillars. So I will skip the first 2 because I'm from the third, so I'll just focus on the third. So I am from the AI innovation pillar. So under AI innovation pillar, what we do is that we are the department that go out to talk to people to help them build AI models if necessary, and do some corporate engagement and training, like what we're doing now today. So later on, I will touch a bit more on the some of the other programs that we have. Okay. So now let's get to the main bulk of today's talk. Right? What is AI? So a lot of you might heard of AI right now. AI can do a lot of wonderful stuff, such as like doing some predictions, or for example, guiding you where to go using Google Map. So before we start, I just want to give a brief overview of what exactly is AI through some examples. Okay. So AI allows the software programs to see, right? So in the past, imagine if you want to program a software to identify cats and dogs, right? So imagine how many lines of codes you have to write just to tell a computer how to separate cats and dogs, right? And it's very hard to do so, right? Are you going to write logics to differentiate cats and dogs, right? Are you going to say, like, for example, nose bigger means it's dogs? Or if there is very furry ears, then it's cats. It's very hard to do that, right? But AI has made it possible now for software to understand environment and see and understand what is going on in the environment in order to reason, act, and adapt. Okay. AI also enables software program to hear, for example, your Google Home and other things that you have right now, let's say your Siri. All this enables the program to understand your languages through natural language processing. AI also allow the computer to speak, right? So for example, when you ask Google Home some questions, it is able to answer you in a very nice, smoothing voice. And most of the time, it can answer your questions correctly, right? AI enables that as well. AI also has enabled robots to feel, and this together allows the robot to move. So AI has progressed to a stage where through sensors, it is possible to allow the robot to understand the environment through touching. And for that to happen, right, the AI has to be capable enough to instruct the program, what should we do next? Imagine a robot standing at a low floor, trying to jump to the next level. It must first understand the softness of the ground before it can determine how high or how much energy is needed to jump, right? That itself is also AI. And lastly, AI allows the software program to learn. So how is it different from the rest? For the rest of the use cases that I mentioned earlier, all these require existing data set. But for the last example, right, for those of you who are students who play Dota, League of Legends, or you yourself are gamers, you know this icon there. That's a League of Legends. So just 1 or 2 years ago, the company called DeepMind has actually programmed a reinforcement programming language that allows the program to compete against itself, right? So imagine a computer version A, a computer version B. After they compete against itself, right, the winner will stay and make a duplicate of itself. And so this competition within itself will keep going on and keep repeating until there's a very strong AI model that's developed. Right? That's what I call reinforcement learning, right? Allowing computer to learn by playing against itself. So that is AI. AI can allow the software programming to replicate human sensors, traditional human functions, to be that way. Okay? And out in the wild also, when you read articles and news, there could be a lot of other things you heard about, such as AI, artificial intelligence, ML, machine learning, data science, right? So what is all this, right? So let me break down for you so that after today, when you read articles about AI, you have a deeper appreciation of what is meant by AI, ML, and DS. So AI is any programs that can sense, reason, adapt, and act. So in the past, right, 1950s, right, when imagine you have an aircon in your room, right, and there's a remote control. Once the temperature goes beyond limit, right, the temperature of the fan of the aircon will go into full blast mode to bring the temperature down. So once they've achieved the temperature, the aircon will turn off, right, or go into the standby mode to save energy. So that itself is really AI, right? So your aircon at home is an AI aircon. It can adapt itself to the changes in the temperature based on some logic, very simple logic. Right? If temperature exceed what you set, then turn on the aircon full blast. Otherwise, go into standby mode. Right? So that itself is AI. But after that, AI has progressed to the next stage called machine learning. Right? So in machine learning, we move from, let's say, rule-based, like for example, if this then that, else if this then that. So we have moved from that logic-based to a statistical approach. Right? So under machine learning, what AI does is that it uses probabilities, statistics and probabilities to determine the chances of something happening. So this is where we stop giving hard-coded languages or rules to the AI model. At this stage, right, the approach is you give data and the answer to the AI. The AI will try to learn itself, learn from data, right? and determine what is the logic behind everything. And it will self-tune itself to develop that tuned AI model. Right? So from AI, we have moved to machine learning. And just recently, we have this thing called a deep learning. So what's the difference between machine learning and deep learning? So in machine learning, we still use something called a statistical approach. But under deep learning, we have moved away from that. So deep learning, the architecture or how is it done is inspired by how our brains, the neurons, the synapses, how they're all connected together. So under deep learning, to put it simply, it tries to model how our brain works, right? And in deep learning, this is where all the fanciful applications happen, right? So if you think about, let's say, Google Home, you think about autonomous driving car, you think about cat and dog image classifier, and other wonderful applications like Siri, all these are powered by deep learning. So deep learning is the next frontier of AI, where it uses architecture that simulates or replicate how a human brain functions. Okay, so that's it for AI, ML, and DS. So among all this, right, there's also another thing called data science. So what is exactly is data science? So data science is it's an intersection of everything here. Right? You have the business domain, you have the math, you have the computer science. Right? So all these three will intersect to give you someone to give someone that's a skill set to do data science, right? That's why data scientists is very rare and they're very expensive to hire, because a lot of the time for someone who graduated from universities, right, they could have one or two domain experts. Let's say, for example, they could be a business grad who are good in math, right? But it's very rare to find a business grad who are good in math and at the same time they can code AI languages. And that's why data scientists nowadays is very rare and expensive to hire. Okay, so data science is a combination of everything that try to build AI models that address business problems. So that's it for AI. So despite all this about AI, right, about replicating the brain functions, right, to do things like understanding environment or separating images into cats and dogs, or even like understand our voices, right? It is not magic, right? At the backbone of AI is just math. So what do I mean by that? So I'm sure all of you will be familiar with this, right? The linear regression function, right? Y equal to mx plus c, right? So think about it, right? Our definition of AI. So our definition of AI is any programming that can reason, adapt, and act, right? So in linear regressions, whenever there's new data point that's coming in, right? Let's say if there's a outlier, right? You'll see the gradient of the lines start to shift towards the outliers, right? To achieve the best fit line. So that itself will achieve the definition that you give for AI, right? So linear regression itself is also an AI, and some AI models are built with linear regression at the backbone of it, right? But of course, not every AI model is built using linear regression. This is just one of it. There are other more sophisticated mathematical models that we use to build the AI model. Okay, but the main purpose of this slide is to highlight to everybody that AI is not magic. It's just math, and even simple math like linear regression is considered AI. Right? So AI started in the 1950s, right? Like I showed earlier, and and over 30, 40 years ago, there's this machine learning and comes about. Then we have this thing called a deep learning that's appeared recently. So maybe wondering to yourself, right? How come there's such a surge in interest, right, in AI, right? AI has been here since 1950s. So why now, right? So all this happens because in 2015, right, Google did a very huge AI publicity. So what Google did was Google actually developed algorithms that can play the Go chess. So Go chess, why is Go chess, right? In specifically, the reason why is because for Go chess, right, the amount of permutations and the amount of ways to play a move is vast. Is a lot. Is beyond what a traditional programming language can handle. Right? And Google has done that with AI, and the AI model developed by Google has beat Lee Sedol. So Lee Sedol is the world number one champion from Korea in this Go chess, right? So with that, right, that drives the interest in the public. Hey, like AI is something that can like beat world #1 player. What if you can use the AI to do other business applications, right? So that drives the interest. And along with that, right, there are a lot of transformational trends that's happening in the industry. So first of all, right, you have the data explosion. So think about that. Nowadays, most of us have at least one smartphone, maybe one smartwatch, and at your home, you have at least one smart devices, right, like Google Home, etc. So there is a lot of data being collected about our environment. Plus, there's a lot of IoT sensors as well that are being used by industries. So all this lead to a explosion in data. Right? With that, we also have an advancement in the algorithms, right? Because once you have non-traditional data sources, like let's say, for example, images, text, you cannot use linear regression to try to make the machine to understand what is the difference between cats and dogs using linear regressions. You have to use things like computer vision algorithm to understand the images. So the algorithms has also advanced to keep up with the type of data that's being collected. Okay. Next, you have the influx of AI talents, right? So nowadays, if you go to any schools, any universities, or in fact online, right, everyone will at least offer, let's say, an AI course, even in a business degree course, right? There's one courses on AI, Python programming. So there's a lot of like talents that's coming into this industry. And lastly, the cost of computing has decreased significantly. So in the past, if you want to build an AI model, you can't to build a very sophisticated AI model. You can't do it on your laptop. Right? Your laptop will overheat and melt. So then, what should we do next? Right? Do you go and buy a server rack which costs $10,000? No, that's too expensive. Right? So right now with cloud computing, everyone has access to the most advanced supercomputer at home. All you need to do is have a credit card and you can just pay Google, Microsoft, or Amazon like a few cents per hour, and you have access to the cloud computing, which can allow you to train AI model that could not be possible without this cloud computing. So all this itself helps to drive that explosion in AI applications and interest. Okay. And of course, along with it, you have all the open source data sets, right? Open source framework. So let's say, for example, in the past, if you want to use a software to build an AI model, for example, you might have to pay a few $1,000s to pay for a software license fee to use the software to build AI model. But nowadays, almost all the AI framework that you can use to build AI model are all free. And I'm not talking about like those low quality AI framework. Even professionals in Google, Facebook are also using the same open source tools to build the AI model. So you can see how everything comes together to drive that the AI in spike for everyone in this industry. Okay. So you might be wondering to yourself, like, hey, like given all these things, right? Then why is AI so difficult to train? Right? So this has to go back to this story where this professor here called Dr. Fei Fei Li from Stanford University. So she did her PhD on this problem. So in the past, right, when people try to develop AI model, they're having a lot of difficulties because they have the algorithms, but they don't have the data sets. So her entire PhD is on the basis that you need good quality data to build a good AI model, right? And through her PhD, she has collected like 14 million images, right, and categorized them. And she has proven that using the same algorithms they have 3-4 years ago, right, with good enough data sets, it is possible to build a good AI model that can outperform human, for example. And she has done that. Right? So it's easy to get cats and dogs images because through a simple Google search, right, you are able to obtain a lot of these images, right? But later I'm going to tell you something very interesting. So just keep this in mind. Okay, so it's easy to build AI model once there's enough data set. Okay, but what if there's not enough data sets? So there's something which I'll talk about later on. Okay, so AI model, you need two things. You need data and algorithms, right? I put 4 data here because I want to emphasize the importance of having good data. Okay, let's look at this. So this is an image, right, of a man standing on the moon. Right? And when we feed this image to an AI model, right, this caption generator, right, so this is what the AI says. Right? I'm not really confident, but I think it's a man standing on top of a dirt field. So if you look at it, it's correct in a way because it's a man. Probably a man could be female as well, but let's say it's a man standing on top of a dirt field, right? Looks like a dirt field on the moon. So that's correct. But the AI doesn't have the context of this is an astronaut landing on the moon, right? And the reason why the AI can't do this is not because the AI is dumb, but it is because it doesn't have enough training data sets to train it, right? So think about it. Everyone here who has a cats and dogs, you'll take multiple pictures of it and put to Facebook and internet to share. But how many of us here have been to the moon and take a selfie on moon? It's very rare, right? Maybe like only a dozens or 20, 50 astronauts have actually gone out to the moon and take a photo of them standing there. So without sufficient data, AI cannot do the predictions. Okay, so let me repeat again. Without sufficient good quality data, AI cannot perform the task required. Okay, later on, I will bring this theory here to the hands-on section later on to emphasize again why this is so important. Okay. So other than data and algorithms, we need something called empathy as well. So technically speaking, empathy is not needed to build an AI model, but it is strongly recommended. Why? Imagine if there is an AI model in the hospitals that talks about, let's say, whether someone has cancer or not. And imagine a patient has been diagnosed with cancer, and all they receive is an SMS notification. You have been diagnosed with cancer. Right? Good luck. It lacks the empathy that a doctors could give or the nurse could give the patients, right? When they communicate that big news to the patients, right? So AI still lacks that kind of empathy in it to do that human soft touch communication, especially when it comes to important communications. Okay. So now after that, let me move to share with you some of the common types of machine learning. Okay. So out there, you heard of a lot of things about machine learning. You talk about like predictions of weather, prediction of stock prices, prediction of student grades. All these falls, all the AI use cases typically fall under 2 main categories of algorithms or the types of machine learning: the supervised and the unsupervised. Let me go through with you what are the main difference between these two. Okay, so first I'll start with supervised. So under supervised learning, right, it requires data and the answer. So let me give you an example. Let's say if you are teaching your students, right, to learn math or English or whatever that is, right, you give them a set of questions, right, and they will look at the question and try to give an answer. If it's wrong, they have this answer booklet with the steps to look at to understand what they've gone wrong. Okay, so there's a question and there's an answer. So as long as in a data sets, right, there is some information about anything you want to predict and the outcome that you want you to achieve, the right outcome, right? This is supervised learning. So things like, for example, stock price predictions, things like demand forecasting, student grade predictions, all this falls under supervised learning. Okay? By showing that enough examples of something, it can learn to do the same. So what are the applications of supervised learning? So we have a few things. First is classifications. So let me give you a few examples below. Right? Spam email. Right? So in the past, before this smart intelligent spam email filter, we will receive a lot of emails from Nigeria or our relative in Africa. Right? They say that we have inherited $1 billion. Send them our bank account and we receive the money. So how AI learn from this? Right? It's not because someone manually go and put in the keywords. What are the keywords that separate one email that's spam versus one email that's not spam. So AI is doing at the background. So every time when you see a spam email, when you flag it, the AI will learn what are the words combination used in the email that determines it's a spam. So the spam email is like an answer. Right? So given the context of this email, the outcome is that this email is a spam. So given enough examples, it is possible for the AI to learn, okay, so in general, as long as you have some text, they are arranged in a certain manner in the text, then it is highly likely a spam email. Right? So other things that AI can do under classification is identify which customers who might not renew their contracts. So this is customer churn. Detect the sentiments of customer reviews. So this is like on Amazon, Lazada, Shopee, where they can look at the review of the customers to understand how they are feeling. So other use cases in education setting could be, for example, whether this student will pass or fail the course, whether this student is at risk of dropping out from school, for example. So all these are under classification. Okay. Classification helps to answer yes or no, this or that, cat or dog. So as long as there's a category of things to try to predict, it is called classifications. Another use case of supervised learning is called regressions. So for regressions, we try to predict continuous value. So things like price predictions, what is the price of the HDB resale? This will fall under regression. Other things could include, for example, like likelihood of rain tomorrow. So these are weather forecasting. So for weather forecasting, student marks, exam marks, grades predictions, that'll be under regression. Okay, so that is for supervised learning. Okay, so under supervised, you have regression and classification. How about unsupervised? What's the difference between these two, right? So the main difference between a supervised and unsupervised is that under the unsupervised, there is no right answer in the data sets, or there's no right answers given to the AI. So the AI will try to learn the commonalities or the patterns in that data sets and try to group the data points together. This is what I call clustering or grouping of data points together. So this is what we call unsupervised learning. Okay. So take a look at this example here. So let's say you give the AI some examples here, like there's a circle, squares, triangles, and rectangle. So if you pass this to unsupervised learning AI algorithm, it will perhaps sort out the figures into three clusters, right? So one cluster could have no angles, one has three angles, and the other one have four angles. But take a look at this, right? In the cluster tree, right, the AI group the square and the rectangle together, right? And the reason why the AI does this could be, for example, all of them have four angles, but AI cannot tell you why they have grouped the data in such a manner. It can only help you to group it, and the data scientists or whoever is using these AI algorithms have to look into each of the clusters and try to understand why the AI group the data in certain manners. Right? If you bring this back to the education use case, right, one of the use cases could be, for example, a clustering of students based on their academic results, right? So let's say, for example, I just making up examples here, right? Because I'm not an educator, but I just making up examples here based on what I understand. So for example, let's say in the past, there's a streaming of students, right? Let's say based on their results, right? You go to class 1, class 2, and class 3. So typically the streaming is done by looking at academic results, right? Purely on academic results. Maybe CCA or leadership if there is anything else to be included, right? So it's very narrow and specific. But what if you have other things about the student, such as, let's say, for example, when the student first came into the school, what is the performance and the current student performance now? So let's say, for example, in the past, this student is let's say D grade, but now it's A grade, right? That's a huge improvement. So if you have this information recorded in a data set, the AI can help you to group the student in a more holistic manner, because no matter how many variables or fields of consideration you pass to the AI is able to try to find similar students and group them in the best way possible And sometimes it may not be something that as human we have the capability to do so, right? So if you look at grade alone, it's doable. If you look at CCA alone, it's doable based on the position in CCA. But if you expand data sets to include things like the first, let's say the family background and other things that they could have achieved, right? Or it could be important in making that segmentations of a different classes they should go to. Uh, the AI will be able to do a much better job than human because they can look at a wider range of considerations. Okay, so other things such as, for example, getting product recommendations from Lazada. So in a lot of the online courses, if you go to, let's say, MOOC or Coursera, how they recommend you courses is through unsupervised learning most of the time. So based on similarities in profile, if a person with a similar profile as yours took a certain course, then the AI is likely to highlight to you or recommend to you a similar course to take. Right? So that is unsupervised learning. There's no right answer. It's up to the AI to determine by itself. So again, this is to recap 4 questions that AI have to answer. A or B, that's classification. Real or not, that's anomaly detection. It also belongs to classifications, but you use it to determine things like spam email. How much, how many, that'll be regression, prediction of continuous value. And lastly, how is this organized, or how should I separate the groups? That'll be clustering or the unsupervised learning. Okay, so these are the typical 4 questions that AI can help to answer. So in a typical machine learning or AI model building process, right, there are 4 main stages that people go through. I'll just use a Hokkien Mee example to illustrate, right? So imagine you want to eat Hokkien Mee, right? You must first determine that you want to eat Hokkien Mee. That's indeed your dish, your dishes of choice, right? So once that is done already, you need to go to the market and buy ingredient and everything else. But you can't just throw all the ingredients into the wok and a pot to cook, right? You have to dice it, prepare it, clean it, marinate it, do all sorts of things to the ingredients before you can start cooking. So once you start cooking, there could be a few ways to try, right? You can do try and error, you can experiment, or you follow your someone else's recipe. At the end of it, right, you put everything on a plate and you serve the dish to your guests or to yourself. So AI model is exactly the same. Okay. Start by defining the promise statement. What is the promise statement that you want to solve? Once your promise statements, you must go and collect all the necessary data. So things like, for example, if you are doing a predictions or student grades, right? So of course, then you need the student performance. Maybe student performance over the past 4 or 5 years. If you have the data, that'd be great, right? So once you have the data, that's not enough yet, right? Because a lot of time, the data might have a lot of missing values, outliers, or even errors in recording, right? Sometimes when you record the data down, maybe you accidentally put a dot or you put an additional 9. So instead of 99, become 999 out of 100. That's not possible, right? So you have to do some data cleaning because otherwise, if you feed the wrong data to the AI, it might learn the wrong relationship as well. Okay. Next, we have the learning part. So that's where the supervised and the unsupervised, which I mentioned earlier, will apply. Like after you have the data, what is the algorithms or method you want to use to approach or build the AI model? Okay, and lastly, once you have built the AI model, right, you need to deploy it. So by deployment, you can imagine that getting a software engineer or a system integrator to take the AI model that you built and integrate it into a software. It could be, let's say, your app or a handphone. It could be a software that can install on your desktop, or it could even be a web application. So you go to the website, you run, and it works. Right? So without the deployment part, right, a lot of the time the AI model won't be able to be served to the general public or to your colleagues to use. Okay, and on this note, right, I want you to make a guess, right? Which stage is the most taxing and time consuming? You have 4 stages here, right? The promise statements, discovery, learning, and deployment. So which stage is the most time consuming? Make a guess, right? The answer is discovery and problem statements. The problem statement and discovery alone take up around 80% of an AI engineer or data scientist time. 80%, right? The learning and the deployment only takes around 20% of the time. And that's why today we are able to do the learning part later on, building a hands-on session. You'll skip through the problem statement and the data collection part because that is very time consuming. Right? And that's also the reason why for any good AI models, or if an AI engineer want to get started on a project, right, they need to have good quality data that's easily accessible, because otherwise they'll be spending a lot of time trying to collect the data and clean them up before they can run the AI model building. And AI has advanced to the stage where to build an AI model at the learning stage, right? Some AI model could be built using just maybe 4 lines of code, just 4 lines. And this short, I'm not talking about one long sentence, maybe this short, and 4 lines of code. That's all it takes to build an AI model nowadays, using all the open source framework libraries that AI engineers typically use. Okay, so again, problem statement identifications is crucial, because wrong problem statements identifications will lead people down the wrong path. Right? So AI and ethics, right? Earlier I briefly touched on the empathy part. Now I'm going to touch on the ethics part. Why is ethics important, right? Take a look at this. So this is very interesting. So there was so previously there's this guy. It's a very funny story. So there's this guy who claims that no, I have built the AI model that can predict whether someone is a criminal or not. Okay, good, right? Like the fortune teller, by looking at your face, right, they can tell whether someone is going to jail or not, whether it's a criminal or not. So when people got very curious, right, how this guy achieved this, right? Then people start to look in your data set he used, right? And end up, right, this guy didn't build a criminal detector. It built a smile detector. Why is that so? So this guy collected a lot of mug shot. Not people going to jail, the mug shot taken by police. So in a mug shot, people are not smiling. They are usually very sad and depressed. Right? They are caught by the police. So they have one whole data set of people in mug shot looking depressed. He also put in a set of data sets taken from, let's say, Facebook, of people smiling, right? People having the happiest time of their life. Anyone here who will put you having a sad face on Facebook to share with your friends? Probably not, right? You will put all the happiest moments of your life on Facebook, of you smiling, playing. So therein lies the problem. One data set of all people who are not smiling because they are mugshot, and one data set of all people smiling having the best time of their life because it's taken on Facebook. So if you look at these two, then it's not actually criminal detector, it's smile detector. One data set is all people not smiling, one data set is people that is smiling. So as long as you're not smiling, you're likely a criminal. That's what the AI model has built, right? Which is a significant flaw in the AI model. That's why the data collection part is very crucial. Okay, and other things that happens as well, even for the big companies that happen is this, right? Let me bring your attention to, let's say, the middle one and the last one. So Amazon and Apple, right? So let me elaborate on the Apple case. So what happens in the past is that Apple want to create this Apple card, right? Apple credit card in the States, right? So they work with this bank, I think it's JP Morgan, to build this AI model that can automatically determine whether someone is eligible for the Apple card. And if you're eligible, what is your credit limit, right? If you're higher, if a higher salary, logically your credit limit should be higher, right? Because you have more spending power. But that's not the case. When the AI model was developed, right, what happened was that, right, there was this couple who was staying together, right? So the wife who's earning a lot more than the man, right? When the couples applied for the Apple card, right, the credit limit given to the wife is significantly lower than the man, even though the man is earning lower and the wife is earning higher. So why is that so? So imagine in the past, right, men used to be a breadwinners of the family. So in a data set, right, if you go back over past 20 years or so, right, the number of men applying for credit cards was significantly outweigh the number of women who apply for credit cards or are credit card holders, right? So when you feed this data into the AI model, right, the AI model might think that, hey, okay, if you want your data set, if you're male, most likely that you'll be you have a credit card based on previous data sets, right? So given that, then probably you're lower risk, right? So I give you a higher credit limit as long as if you are male, right? If you are female, I mean, previously based on data sets, right, there's very little data point of female having credit card. So then the AI might infer that, women are riskier because there's less credit card given to them in the past. So the AI might make the wrong inference and think that as long as you're female, you should be given lower credit approval because you're high risk. Okay, so the reason why I want to elaborate on this is because I want to bring your attention to, let's say, other things that you can do for your for AI models, right? Let's say, for example, if you want to build a student's grade predictions, right? What could be the higher biasness in a data set that could affect the predictions outcome? Okay, so other industry also kind of things like fate. So this by Microsoft, right? Talk about how do you access the AI model to ensure it's safe. Okay, so now I come to the last part of this my sharing. So this is a bit on AI jobs and career. So Milton Friedman is a very famous economist. So one day he was in India on a road trip, right? So he saw a lot of the workers, right, using shovels to shove the roads, soil, rocks, right, instead using an excavator at the roadside. So this economist got very curious and asked his guide, right, hey, why don't the workers use excavator instead of shovels? It's more productive, right? So the answer is, if they use shovels, right, they give them more jobs. Then, of course, being a smart economist, his answer is that, oh, if that's the case, then why don't give the workers spoon, right? If you use spoon to dig the road, you can hire more people, right? So that's the funny story behind it. So AI has come to a point where it can replicate a lot of the traditional human tasks. So one other task is this, right? Let's say reviewing of NDA, non-disclosure agreement. So the company has developed these AI algorithms in the States that can achieve better performance than human lawyers in reviewing NDA and at a shorter period of time. But surprisingly, for the lawyers, right, who have been beaten by the AI models, right, look at the comments, right. So they were not disheartened. So they are saying that, hey, like AI helps us to focus on things that are more interesting and free up more time for higher value tasks. So what do we mean by that, right? So it'll be something similar to this, right? So every job is made of tasks, right? And if the AI model can do or take over some of the tasks, right, then of course, right, let's say you have some boring task, right, you can pass the task over to AI, right? But then in a in a typical company, I mean, if you can pass some tasks to the AI, do you think the boss will let you go home early? Unlikely, no, right? So the boss has some tasks and pass it to you to do. Right. So see such a joke here. And the purpose of this slide is to tell you that AI allows people to focus on higher value tasks in the typical professions, right? So that they can give the lower value added stuff to AI to do. Maybe things like I don't know, maybe marking of homework, things like that can be done by AI, so it can focus on things that are more higher value added, let's say coaching or mentoring of students, for example. Okay, so what we think is that managers will not be replaced by AI, but managers will be replaced by managers who uses AI. So it's like if someone else who knows how to use AI to do their job better, they will have a competitive advantage over those who don't. Right? So this will be the future, even for lawyers and doctors, accountants, engineers. Right? This AI will change the way a traditional job is being done. Okay. So with that, so I'll just briefly share a bit about AI Singapore as well. So at the start, I share a bit about AI Singapore, what we do. So over here, I also want to share a few things that we have also. So AI Singapore have this thing called an AI apprenticeship program, where we work together with companies, be it public or private, to develop a model together. So as long as the organization has the right problem statements and the appropriate data sets, right? AI Singapore, with some fundings from the government, NRF, we can collaborate with the companies over 9 months period to develop the AI model for them. So at the end of the 9 months, right, the IP of the AI model belongs to the organizations, right? AI Singapore don't take anything from it. Okay. So so typically this is how it goes, right? So the organizations provide the data sets and problem statements. AI Singapore provide the AI engineering expertise and work with the company over 9 months periods. We also have this thing called 100E for research, right? So I think AI Singapore is also doing something there with on a project on the education space on I think on the personalized learning journey. So that was under the 100E for research. If you know about that in your organizations. So this is how we help companies to embark on their AI journeys. And we also understand that sometimes it's very hard for companies to come up with good AI use cases. And that's why we have this thing called the AI advisory events, where we do educate, explore, discover, and prepare. So under this journey, what we want to do is that we help to bring the, the, the organizations from knowing AI all the way to getting started on AI. We also have this thing called AI discovery, where we run a design sprint workshop to help the clients or the companies ideate good AI use cases. Okay? And this summarizes all the programs that we have. So we have programs from the primary school, AI for kids, all the way to working professional and certified professionals, right? So we do run AI for kids and AI for students. So I think last year or earlier this year, we managed to get Facebook to sponsor the office venue, and our AI engineers actually conducted a lesson for the kids, like primary school kids, to teach them very simple way of building AI model. And in between the certified professionals and the schools, we have these other programs like AI for industry that working professionals can take up online if they wish to embark on deep skilling themselves to learn how to use AI. Okay, and this is my last slide. Thank you very much.
Thank you, Tern Poh, for a fascinating introduction to the world of artificial intelligence. Before we move on to the next segment on AI use cases, we would like to take a few minutes to address a couple of questions from participants. So, John would like to know what would you think about semi-supervised learning and reinforcement learning? Interestingly, from an educational perspective, this two seems to be the most promising. Semi-supervised due to the existence of the data, but difficulty to collect at a large scale. Reinforcement learning mainly due to the continuous presence or supervision of a mentor or teacher.
Okay, I'll answer the second part first, reinforcement learning. So technically speaking, reinforcement learning sounds like a good deal, right? You program a programming language, right? It compete against itself, you learn, and the winner will be kept, and it duplicate itself and compete again. But for reinforcement learning to work, it requires a very stable environment. And that's why a lot of the use cases nowadays is in games. Let's say StarCraft, things like League of Legends. All these video games have very specific environment. There's a map, right? You can't go beyond a map. There is a set actors, and the things that the actors can do are pretty much fixed, right? Like this wizard can cast spell, but cannot like walk on water, for example. So if you put this reinforcement learning in a real world applications, right? Yes, a lot of limitations. The first limitation is that it assumes that the environment is running at is stable, and all the rules are known. So if I use this in an education settings, right? It's going to be very tough because in the educational settings, that could be all of unknowns yet. Even as of today, right, there's still a lot of research ongoing. Let's say, what are the things that a student should take in order to improve his grade? For example, should go for more exams or more tutorial? So all these are question marks, perhaps. So if you put reinforcement learning to the real world, it might not be that feasible. And secondly, it's very expensive to train the reinforcement learning to play the League of Legends games, right? DeepMind spend, I think, millions of dollars, a few hundred millions of dollars to train the AI model because it's very computationally expensive, right? So then the next question is like, would organizations spend hundred millions of dollars to train an AI model, which might not succeed at the end because there's all unknowns, right? So that's the answer to your second part of the question. The first question is on semi-supervised, right? Yes, you're right. Yes, a lot of promises there. And the reason why it's being developed is because, right, a lot of times, a lot of the data is not labeled. So the use cases of semi-supervised is that, right, you have a set of labeled data. Let's say, for example, given a student performance, and the interventions given by the teachers, right, or by the organizations, the outcome is just say from B to A. So that is the answer, right? But you cannot have the data sets for, let's say, hundreds of thousands of students, right? If that's not available, because some of the past students, right, the results might be captured digitally in the database. So yeah, some students with labeled data sets, some are unlabeled. So by using semi-supervised, right, it helps to the AI to try to like make a smarter guess on what is the actual outcome of the students and use that as an input to the AI model. So that is one area that is up and coming, but there's also a lot of uncertainty behind it because when you ask AI to make assumptions about what actually happens to students, right, there could be some errors there as well. So because of all this, right now what the industry is going towards is instead, right, to answer both of your questions is that people are in the same industry, they are coming together to share data. By after they anonymize the data, right, they will share with each other. Let's say, for example, Nanyang Polytechnic could share data sets about their student in engineering course with, let's say, Republic Polytechnic and Singapore Polytechnic. So the student, the kind of data they record will be very similar, right? So one polytechnic by themselves might not have all the data, but by consolidating the data together, right, and make it let's say industry collaboration, then the polytechnic can all benefit from it, right? So it's only by collaborating and combining data sets, right, everyone will win. If any party want to go it by themselves, right, no one will win because no one will be able to develop the AI model due to lack of data sets. And that's the reason why right now this is the trend of the industry as well, where there's a lot of industry collaborations to cross-share data sets after they have been anonymized, or there's this thing called federated learning, but I won't go into that area.
Okay, thank you, Tern Poh. We will pause here for now and address the rest of the questions later with all the presenters. Meanwhile, feel free to type your questions in the Q&A text box, and we will try to our best to address them at the end of the session.